Okay, so for this one, you have to know that sine squared of x is same as sine of x squared. And if you didn't know, then it's hard to proceed. So that's absolutely essential. And then once you write it in terms of integral of cosine of x sine x squared dx, you see that the derivative of sine is cosine, so this must be artifact of the chain rule, and this should be your u. Right? So you naturally choose u as sine of x, and I gave you time to try out this question, and I was walking around. Everyone was doing fine, but I still want to show you a slightly different approach. Okay. So one thing is, if you have u equals to a function of x, then du over dx would be f prime of x, right? And you can multiply the dx both sides, and you can write du equals to f prime of x times dx. And this is going to be the choice. I mean, this will be the thing that we will always write. So we're going to skip this part and go straight from here to there. You can do that, right? Okay. It saves you a little bit more time. And it actually helps you to understand some other things later on. So there's like something called integration by parts, where we have to do some calculations similar to this one. So it's good to train your mind to go from here to there straight away. Okay? So if we do that, what is du? Sine. This formula says you have to differentiate the function and just attach dx. That's all it's asking you to do. Okay? So we differentiate the sine x, which gives you cosine of x, and multiply it by dx. And assuming that you did solve the first question, you probably noticed that this is exactly what you have, except that you probably divided by cosine to the other side, right? But here's another thing that I like to do. Sometimes, when you look at the integral, you can actually identify which one is exactly the same as your du. See this one times this one? These two put together, that's same as du, isn't it? Right? So if you notice that you don't have to like solve for dx and plug it in and cancel. You can just go straight to the answer that way. Right? So what you can do is you can do the integral u squared, because sine squared x is really sine x to the squared, and u is sine x. And this cosine x dx turned into du. Now these, you might think is like such a minor detail that it might not affect anything at all, but you know, the shorter you can make your solution be, there's less chance of making a mistake. And the shorter it is, it's easier to remember, understand, and all that. Okay? So these slight improvements I'm showing you are really the things that you would want to do. Okay? All right, so what is u squared integrated by u? 1/3 u cubed, and then plus c. Okay? Again, some people forgot this. Almost forgot this. I was trying to yell. Okay, corrected. So sine of x cubed plus c. And by the way, you should also write this answer in this format. So the trig functions often ends up having like cube or some other things. And mathematicians at some point got tired of writing so many parentheses, so they made a shorthand so that if you put 3 here, that's what that means. Okay, so this is equivalent to saying 1/3 of sine of cubed x plus c. Okay. All right. Now let's try the second one. And I want to challenge you to yet another simplification, but this is, if you do get used to it, this is like a really wonderful thing to do, but it might be too much. But let me show you the second way that some people do. So which one should you set u as? Yes?
X squared plus 1.
Yeah, this entire thing inside, because the derivative of this entire thing is 2x. And this is the nested function e to the 1/2 power. And what you want to say is that d of x squared plus 1, what do? You apply the derivative and just attach dx. That's the way you differentiate a function, right? Yeah. So d of a function means you get that. And the reason is here. And you can rewrite this as integral of x squared plus 1 to the 1/2 power to d of x squared plus 1. See what I did there? I'm actually not writing the u. I'm just writing x squared plus 1. It's the same idea, like think of x squared plus 1 as some really old like ancient character that we don't know how to read. Okay? So it's just one character. So it's like one character to the 1/2 power of d of that character. And what's the antiderivative? Well, you just apply the power rule, right? Yeah. The power rule says add 1 to the exponent. What do you get if you add 1?
3 over 2.
3 over 2. And what do you put in front? 2 over 3. And then plus. Done. So it's shortened to the maximum. It might be too much for you. Yes, you have a question.
I thought that we said u equal to x squared plus 1. How can we put in x? Or was it du?
This is really the u substitution, except that in some lost ancient civilization, their u looks like x squared plus 1. Do you see it?
Okay.
So if we use the modern character, this would be u to the 1/2 power du. Isn't that u substitution?
Right.
Do you see it? Yes.
I don't see where you cancel out the 2 by.
Oh, no. So 2x times dx is d of x squared plus 1. Yeah, there is no cancellation because we just say these two multiply this thing. All right, now, if you're unhappy, I can still show you the u substitution way. So u is equal to x squared plus 1, right? And du would be 2x dx, right? And then dx would be 1 over 2x du. And the integral would be 2x times square root of u, 1 over 2x du. Let's rewrite the square root as 1/2 power. Then you end up with, since these two x's cancel, you end up with u to the 1/2 power du. And it's the same calculation. You add 1 to the exponent, which is 3 over 2, put the reciprocal, plus c. And u is x squared plus 1, so it's 2/3 x squared plus 1 to 3 over 2. But what I'm trying to say is that I'm compressing all this into very short solution where instead of writing u, I'm using some ancient character that looks like x squared plus 1, but it's really not. It's some one letter. Okay? And you can compare this one with this one. This is exactly the same, right? U to the 1/2 power times du, x squared plus 1 to the 1/2 power times d of x squared plus 1. So that's what I meant.